Hello, welcome back. Okay, so we are going to dive right into surface area. So I think we did enough review of area of two-dimensional figures. Now we are moving on to three-dimensional figures. And we're going to start with page 124. These are actually the last two lessons of e-learning. Oh my god! And then you'll have a quiz. So we'll do these two lessons. I'll put together a short little quiz and you'll turn that in next week. And then we'll be done. It'll be the last week of school. You guys will be going to school, cleaning out your lockers, returning any textbooks that you have, and so on. Okay, page 124 is on the surface area of prisms. So I'm sure you've heard of a prism before. There's rectangular prisms and there's triangular prisms. There's all sorts of prisms, but those are the two that we will focus on. So surface area is the area of the surfaces, okay? So if you're thinking about this as like a present, like if you just like wrapped up a new pair of shoes for your brother, sister, mom, dad, whoever, the surface area is like how much wrapping paper does it take to cover this? So the surface area is just the space around all of the surfaces of a prism. So think about it as like wrapping paper, or if you were painting a prism for some reason. So it is going to be a little bit trippy on your brain because you kind of have to be able to picture things, which is something that I personally struggle with. So things like this are kind of hard for me, but we're going to use a whole bunch of highlighters and hopefully that will make it easier. So if you haven't already, go ahead and grab maybe 3 highlighters and let's get to it. This thing will focus. All right, so rectangular prisms, which are prisms made out of rectangles, aren't too bad, and this is a general formula. It's really nice because it does actually have a formula. Some prisms, you just kind of have to figure it out and be like, oh, that's a square, that's a triangle. But this is basically taking the length and the width and the height of the prism and doing every combination possible. So you have 2 times the length times the width. You have 2 times the length times the height. And you have 2 times the width times the height. So those are all the combinations. LW, LH, WH. You're going to add those together. So if you really want to understand like the concept of this formula, think about the fact that there's all these rectangles throughout the whole prism. So you have these 2 on the left and the right, which are 2. Okay, that's where that 2 comes from. And then you have the 2 on the bottom and on the top. So that's where those 2 come from. And then the last 2 is this front rectangle and this back rectangle. So there's 6 surfaces here. 2 plus 2 plus 2. There's 6 surfaces in any rectangular, prism. So I'm going to try to teach you like conceptually how to do this, but you could just use a formula and make sure you make every combination possible of these 3 numbers. So let's first look at what is length and width and height. That's what these L, W, and H's stand for. L stands for length. I'm sure you already know this. W stands for width. And H stands for height. So if we're talking about the prism, oh, you can't see that. If we're talking about the prism, the length would be 12. So the length of this prism is 12. The width, like how thick it is 2. And the height is 4. So you would do 2 times 12 times 2. 2 times 12 times 4. 2 times 2 times 4. Let's think about them as actual rectangles. Finding the area of this rectangle right here. So I'm not necessarily following length and width going first. I'm just seeing, okay, I have this rectangle, and I know that the area of it would be 2 times 4. Where else do I have another one of those rectangles? We have one here on the left, and we would also have another one over here on the right. So another thing you need to understand about rectangular prisms is if this is a 4, then this is a 4, that's a 4, that's a 4, because rectangles, right? If this is a 2, this is a rectangle, then that would also be a 2. So these rectangles, these yellow ones, we have 2 of them, and the area would be 2 times 4. Okay, so let's look at some more rectangles. We have this rectangle on the bottom. And if we have this rectangle on the bottom, where else could we also have this rectangle? That's yes, on the top. So we have 2 of the same rectangles, one on the top and one on the bottom. They have the same dimensions. So the numbers attached to these blue rectangles are 2 and 12. To find the area would be 12 times 2, or 2 times 12. And we have 2 of them, one on the top and one on the bottom. So 2 rectangles whose area is 12 times 2. Are we following? Alright, that is not all of the surfaces of this prism. That's only 4 sides. 2 plus 2 is 4. We need 6 sides. So we have this rectangle here in the front. You see her? She's right there. We have this guy. It's a rectangle. It's the one in the very front. At least that's how my eyes perceive it. And what are the dimensions of this rectangle? We see the 12 is the base, and the height is 4. So the area of that rectangle will be 12 times 4. And we also have 2 of these. There's this one in the back. So we have the one in the front and the one in the back. Now it really starts to look messy and gross at this point, but hopefully you're seeing what I'm trying to do is just bring out those rectangles for your eyes to see like each individual one. So surface area, the concept is adding up the area of all 6 surfaces that encases this prism. So now we really just have to do PEMDAS. We're going to do the inside of the parentheses. So we have 2 times 8 plus 2 times 24 plus 2 times 48. Remember, PEMDAS is how you do math. So now after parentheses comes multiplication. 2 times 8 is 16 plus 2 times 24 is 48 plus 2 times 48 is 96. So we're going to now add these numbers together. 16 plus 48 plus 96 is 160. And this is still area, so we have not entered the 3-dimensional space. All we're doing are these surfaces, which is still actually going to be 2-dimensional, because all I did was find the square inches, like how many square inches of wrapping paper would be needed to wrap this present. So I did a similar diagram for number 2. Go ahead and try number 2 a little bit. Alright. let's look at number 3. So, if you're kind of catching on to the formula, you could just jump right ahead. You don't even have to do any highlighting and say, okay, I know I need to combine 9 and 17. I also need to combine 9 and 24. And the only other combination left is 17 times 24. So that's really how the formula works, at least with rectangular prisms. Just make sure you do every combination possible. So like the 9 by 17, that was the top and bottom rectangles. So we had that one on the bottom, and if there's one on the bottom, there's also one on the top. Alright, the 9 by 24. 9 by 24, 9 by 24 is the right rectangle and the left rectangle. So we have a 9 here and a 24 there. So it took my eyes a second to see it, but if that's a 24, then this is also a 24. So that would be the rectangles on the left and the right. And then the 17 by 24 are the rectangles in the front and in the back. So we have this one in the front and also similar in the back. Like I said, by the time we get to our third highlighter, it starts looking like a headache, but that is the concept. Identifying all of the rectangles, finding the area of them. All of these 9 by 17, 9 by 24, that's base times height. It's the base times the height of the rectangles. Okay, hopefully I'm making sense. I'm recording this pretty late. I don't know if I'm going too fast or what, but remember, you have the internet at your access, okay? So if you are confused, Google surface area, Maybe I don't say things the way your brain likes to hear them. So just remember, you have all sorts of resources online. All right, let's go ahead and do the PEMDAS. So we have 9 times 17. Don't know what that is off the top of my head. That's 153. So we have 2 times 153 plus 2 times 9 times 24 is 216. Parenthesis. Plus 2 times 17 times 24. Of course, 408. Just kidding, I had no clue. And multiply all these by 2. So 153 times 2 is 306. Plus 216 times 2 is 432. Plus 408 times 2, 816. So we just need to add all these numbers together. I'm getting 1,554 centimeters squared. All right, Julio, go ahead and try 2 and 4. They're really similar. Rectangular prisms. All right, triangular prisms are the next set of problems, and this is a little bit trickier because there's not a specific formula for triangular prisms. For one thing, you can see that there are 2 triangles, right? Here's one of them right here, and here's the other one. So there will always be 2 times 1/2 base times height. So this is referring to the two triangles. That is an S for triangles. So that is the area formula. Remember, we're doing surface area, which is the area of the surfaces. So we have two triangles in a triangular prism. And then if you think about a triangle, triangles have three sides. So that means there's three rectangles going around the triangular prism. And I usually have like really cool tangible prisms that I pass around the classroom for you guys, for your brains to like picture it better. But I don't have those because, you know, I'm at my house. I'm not in my classroom. So again, we have Google. I can try to find maybe some models, some GIFs or something. But if you think about it, if you let your eyes see it, there's three rectangles going around this triangle. So basically, to do the surface area of a triangular prism, you need to do two triangles plus the area of three rectangles. And these three rectangles, sometimes all three of them are the same, sometimes all three of them are different. Why? Because there's three different types of triangles. You know, there's equilateral, there's isosceles, and there's scalene. So if you have a scalene triangle, then that means all of your rectangles are going to be super different. Okay, let's just get right into it. I feel like I'm over-explaining. So number 5. If we let our brains take a second and look at this, we see that we have an isosceles triangle. So this triangle has a 5 right here and a 5 right there. That makes it isosceles. So that tells me if it's isosceles, there's two rectangles that are the same. So let's start with the area of the triangles. Right here, they drew in the height of the triangle. That's what this line is right here. So they're telling you that the height is 3, and we can trust it. They drew in the line. I don't see the right angle, but I'm going to trust it. It says h equals 3, so they're telling us height is 3. This line is hitting the base of the triangle, which is also 3. So for our triangles, we have 2 of them. Area of a triangle is 1/2 base times height, 3 times 3. Okay, I need to add to that the area of the rectangles. So let's look at our rectangles. We have one rectangle on the bottom. So we have this blue rectangle on the bottom. It is 3 by 7. I don't see any other rectangles that are the same size as the 3 by 7. So since it's a rectangle, I'm going to just do base times height, 3 times 7. There's no 1/2 here because it's a rectangle. Rectangles just have the regular old base times height. And I just need to rearrange real quick because I'm tired of writing on the notebook. Okay, that's better. So we have that blue rectangle. Let's see what else we have. So we have this rectangle on the front of the triangular prism. Okay. And that is going to be 7 by 5. Now since we have 2 5s, I know that this rectangle on the back is also going to be 5 by 7 because again, like I mentioned earlier, it's an isosceles triangle. So that means 2 of the rectangles are going to end up being the same. So if I have 2 of the same rectangles, then I can put a 2 in front of the parentheses. Sorry, it's blurry. I'm focusing it. I'm going to put in 2 in front of the parentheses since I know I have 2 of the same rectangles. So I have this 7 by 5 in the front and in the back. They are both the same, the front and the back rectangles. 7 by 5. Alright, I just want to make sure I have 5 sides total, because if you think about a triangular prism, they have 5 surfaces. So we have 2 here, 1, 2, 3, there's 1 right here, 4, 5. Okay, cool. So we have all 5 surfaces. Alright, so let's do the parentheses, PEMDAS. We have 2 times half of 3 times 3. 3 times 3 is 9. Half of 9 is 4.5. Plus 21 plus 2 times 35. Alright, let's multiply those 2's. So we really have 9 plus 21 plus 70. And that will give us 100 inches squared. Alright, number 7. We got this. I know this is quite a long video. You're doing great. I'm sorry about it, but you're doing great. Okay, number 7. Another triangular prism. So we have this triangle in the front. And with another height drawn in, you can see this dotted line is the height of the triangle because it makes a right angle with this other side. And that same triangle is also in the back. So we have 2 of these triangles, one in the front and one in the back. Since they're triangles, we need 1/2. That is the area of a triangle. So 2 times 1/2. The base is actually going to be 11 because of this right angle. The right angle tells you which numbers are the base and the height. Remember that from previous lesson. So we have 11 times 7.7 is the height of the actual triangle. So we're not talking about the entire prism, we're just talking about the triangle. Alright, let's add in, I don't think I'm going to have enough room, but let's add in the 3 other rectangles. So we have the rectangle on the bottom. And I'm trying to see if there are any other rectangles like that one. And I don't think there are because we have all these different numbers. We have a 10, we have a 9, we have a 3, we have 11. None of those are the same. So that means this is a scalene triangle. That tells me that we have 3 different rectangles. So this rectangle down here, I see that there's a 10, and this piece has to be 3 because this piece is 3. So the area of this rectangle would be 10 times 3. Plus, I'm just going to continue it down here. We have the rectangle kind of here on the left. I'm just going to use my pen to draw it. We have 11 by 3 right here on the left. So our area, 11 times 3. Plus our third rectangle. Almost all of these are highlighted except for this guy on the right. You see him? There he is. This rectangle. Its area is found by doing 3 by 9. Wow, okay, so I think we got all 5 surfaces. We have 2 triangles and 3 rectangles. So let's do PEMDAS and figure out the surface area of this triangular prism. So I'm going to type in half of 11 times 7.7. Ooh, fine, we get a decimal. So we have 42.35. And don't forget that 2 out in the front. I haven't multiplied that yet. So we have 2 times 42.35 plus 10 times 3, 30. plus 11 times 3, 33, plus 9 times 3 is 27. So let me multiply that by 2. I get 84.7 plus 30 plus 33 plus 27. Let's just type all that in the calculator. 174.7 feet squared. Alright, so try out number 8 like that. It's very similar. The picture looks a little different, but it's the same exact concept. Okay, good job making it through this video. I know it was a doozy. It was kind of a lot for the brain to process. Let me know if you have any questions, okay? Keep in mind, this is the second to last lesson, so you're almost done, almost there. All right, see you soon. Bye.